In this video, we will analyze a missense variant in the SCN2A gene for eligibility towards ASOs. We first begin with a variant check. We can also conduct an ASO check at this stage, but I'll be doing this later on in our analysis. Using variant validator, I input the transcript ID and variant notation. No error message is received, so our description is correct, and the protein description matches. Next, we check the inheritance pattern. As suggested by our guidelines, we can use OMIM. Here, we see that all phenotypes associated with SCN2A are inherited in an autosomal dominant manner. Next, we check the pathomechanism. We can also check for haploinsufficiency at this step, but I'll be discussing these strategies later in the video. If we look up the variant on ClinVar, one of the databases recommended in our guidelines, we can see that functional studies have shown this variant to have a gain-of-function effect. This can be further validated in a paper by Barecki et al. In 2022, which shows that the variant is gain-of-function according to dynamic action potential clamp experiments. We now know the inheritance pattern and pathomechanism of our variant. Our variant is not associated with splicing defects, so we can therefore move on to step 4, which is the identification of relevant guidelines. Since our variant is autosomal dominant and gain-of-function, we can assess for eligibility towards either exon skipping or knockdown ASOs. For this example, we will evaluate the variant's eligibility towards knockdown ASOs. This is because this variant is found in the last exon, meaning it is not eligible for exon skipping ASOs, according to our guidelines. More detail on evaluating for exon skipping eligibility can be seen in the CTSF example. Furthermore, we see an asterisk by both exon skipping and knockdown strategies, which indicates a possible need to develop an allele-specific approach. Though designing of an actual ASO is beyond the scope of these guidelines, it is something one should consider to ensure that only the transcript containing the variant is targeted by the ASO. To begin our assessment for eligibility towards knockdown ASOs, we want to evaluate whether haploinsufficiency or loss of function is also a cause of disease. If we search up SCN2A on ClinGen, we see here that there is sufficient evidence of haploinsufficiency being a cause of disease. We also see that this gene has a PLI score of 1. PLI scores greater than 0.9 indicate that the gene appears to be intolerant to loss of function variations. Though haploinsufficiency seems to be a cause of disease, it is not necessarily an exclusion criteria. Knockdown ASOs can still be considered if the disease caused by haploinsufficiency is less severe than the disorder caused by gain-of-function or dominant negative variants. Though phenotype considerations are beyond the scope of this guideline, one can consider using OMIM, PubMed, or gene reviews to assess the genotype-phenotype relation. In a paper by Barecki et al., the phenotypic spectrum of SCN2A-related disorders is laid out. The pink or red boxes indicate phenotypes associated with gain-of-function, and blue boxes indicate loss-of-function phenotypes. The phenotypic groups associated with SCN2A developmental and epileptic encephalopathies are indicated in the gray box, which encompass both gain-of-function and loss-of-function phenotypes. The early infantile phenotypes can be considered a spectrum of clinical severity associated with biophysical gain-of-function, while the later onset epilepsy phenotypes and the intellectual disability and autism spectrum disorder without epilepsy are both associated with loss of function. Arguably, the phenotype associated with loss of function is less severe. Therefore, according to our criteria, this variant is unlikely eligible for knockdown, since it is gain of function and haploinsufficiency is a known cause of disease. Since the variant is autosomal dominant, one would ideally design an ASO that targets the transcript containing the variant. However, an ASO known as elsunersen is already being used clinically. This ASO is non-allele specific and has been shown to reduce seizures, improve behavioral activity, and increase survival in SCN2A mouse models. Therefore, we classify this variant as eligible towards knockdown ASOs, given that an ASO already has been developed and shown to work with available functional evidence.